Hey, what's going on? Today I want to talk about geometry. Recently I watched a video about a girl explaining four dimensions and time and stuff like that. And she started with the first dimension, of course, and then went to the second and the third. And then she started to bring up time. And she described time as being cyclical or repetitive. So you start at point A, you end up at point B, but what point B really is the beginning of point A. So it's like a loop. And she wants to describe a torus, but then she avoids describing what a 4D torus looks like. So it bothered me because she went all through all the dimensions and stuff, and then she's just like, "Well, we can't imagine what a 4D torus looks like." Uh, so just skip, and then she just continued to describe like what higher dimensions were or something. I didn't even finish the video before I got inspired to, I guess, show my work of what I think a four-dimensional torus looks like. And I'm just, spoiler alert, I'm not good at drawing it, but I have the theory laid out. So we're gonna start. I'm gonna turn the camera sideways. Maybe I won't. I don't know. I just don't want to reveal it all immediately. So we start with a dot, and then we go to the line. I'm gonna turn it sideways. If I don't know. It's whatever. So you go from a dot to one dimension, and what she describes is time will loop. So like you start at point A and you go to point B, and it'll loop. So you go, and what this means is she wants to connect the loop, the string or whatever, so that it makes a loop. That way you're continuing to go on that string forever. And then you've got a square. You've got two dimensions, length and width, whatever you want to label those as. Length, width. Then you've got a circle, same thing. And what she describes specifically, one rule she states as a manifold of space is that the shape you zoom in on will end up being a straight line if you zoom in far enough. I don't know if that's like accurate with my specific shape here, but the fact that it's a circle is I don't know the right word. The fact that it's a circle is granted that it is a manifold of space. However that makes sense. So you can zoom in on it and it'll eventually be a straight line. An example is Earth. And we get up to three dimensions, so like a cube and then a sphere. So like I said, Earth. And so we can go down here, and I just demonstrated her idea of what she meant by connecting the loop. And so I followed her logic. And first I started with the dot actually. She didn't do that, but I just felt like it was appropriate to include the looping of a dot as well, just to have that there. But then you loop the line, the one dimension, and then you loop the two dimensions, and what you get is a cylinder. Or you can get, and you connect, so what you do is the cylinder, if you make it into a circle, makes a torus, a donut, one of these shapes. So we move on. We got a circle. If you connect the circle in a loop, you get, I assume, a sphere or a taco. You can connect, so you fold the two ends of the paper and you'll get a taco shape. Or you could get a sphere if that's the direction you want to go in, but either way, you get a loop around in a circle. And she stopped at this. This is where she stopped, because she drew the cube, and then she was like, well, there's no way we can like describe how a torus looks or whatever. So I went and finished her work for her, basically. And this was the next shape she should have drawn. And what this is a 4D cylinder. It is not a torus. It's a cube. And then, so we connect the lines, like here. But instead of doing it in one dimension right here, we've got two. So we got boom, 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 boom. I did it everywhere. And I felt it was appropriate since it's 3 dimensions. I said 4D cylinder. This is, I guess, what I don't know the right word. I imply the 4D cylinder here. But, yeah, so we got boom, boom. Because what I have to do is you have to connect A to B, and then A to B, and then A to B again. And then you also have to do it on the sides as well, because it's 3 dimensions. It is not just this, 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 this. It's here, 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 and then the sides as well. And so this is where she stops. She said, "We don't know how to imagine this." Well, you just keep going. You just keep drawing the thing. And so you can imagine where this can lead to in terms of being a cylinder or a torus. And then I did a circle as well. I did these little digit lines or whatever you want to call them, just to sort of imply that because it's a circle, you can have a dot or a starting point anywhere on the circle, and then connect the dots from there. But I just went ahead and did 4, just to demonstrate the idea with the circle. And then I went ahead and asked myself, this was what really had my curiosity piqued in the first place, was what happens if you condense a dimension? When you do so, the implied dimension that we're talking about also condenses until it doesn't exist anymore. And I realized something, that when scientists or mathematicians or physicists or whatever talk about condensing dimensions in math, you also have to sacrifice the fact that you also have to sacrifice the implied dimensions that are included. So if you want to sacrifice a dimension, and so this is time we're talking about. Like this is what it is about, is time. We're discussing the 4th dimension, which is time. And so she wants to loop the line. But what I found out in my view of things is when you condense one dimension so you can demonstrate another dimension, the dimension of time collapses too. So you want something to go from like 3D down to 2D, but the dimension of time has to collapse as well. But anyways, I'm not too sure about that. It's just been something that was on my mind that I had to get out. But what I did was I used it to condense this idea, her idea of illustrating time, into one dimension. So what I did was, in this demonstration, I condensed the dimension of depth, so that the implied dimension of time became no more. So too did these 2 dimensions, where you connect both sides. They collapsed into one as well. So this is what happens when you collapse a dimension. These 2 connect into one, and the dimension of depth collapses. And this is how time became. This is what I did to go from here to here. So I collapsed the dimension of depth, implied time, and then drew this. I would call this 3.5 dimensions of whatever shape we're going with here. And then I added another dimension of time on top of it, or whatever you want to call this. I'm not even sure what kind of dimension this is, except in one view it could be the fact that this tube loops. It's a cylinder. And what I realize is this shape is literally just two cylinders. That's all it is. When we go back all the way here, that's all this is it's a cylinder here and a cylinder here. That's all this became, with the dimension of time being implied, and then this extra bit is the implied dimension of 40. So you want to loop the tube. You want to loop the tube. But what I realize is we still have a dimension of depth that we have to get through. If we want to make... So this is a cylinder. This is... Whatever dimension this is in, this is a cylinder. Right? But this is still in two dimensions. This is why I called it 3.5, because I didn't really know where it lied in terms of dimensionality. But we did collapse the depth. There is no depth here, but the implication of it being connected into a new dimension, a higher dimension, is there. So you've got, and that's what I did here. I connected each tube, boom, 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 boom. And I moved on. And I added the dimension of depth. It's very hard to tell. I'm not the best artist at this point. But I added the dimension of depth to this object. And this is what I call a 4D cylinder. It's literally just 4 cylinders. 2 stacked this way, 2 stacked this vertically, 2 stacked horizontally. And actually I have something else in mind now, because this is just basically this is only in 2 dimensions, except that it goes with depth. So we've got height, length, width, and now we've got depth. Which this is what this lacked. So now we've got depth. And this is what I would call a 4D cylinder. So I moved on and I decided to describe what a torus looks like. And what I did was I connected the tubes. It's very basic. I know, like, it's not quite up to standard, I guess you would say, but this is the idea. I connected all of the tubes, so you've got tube, 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 right? Tube, 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 tube. Connected the tubes, and I created these shapes. So you've got donuts, you've got I did some rings just to make it very simplified. I did this version, so there's a cylinder, there's this donut, and then there's this ring. So I did the cylinder, there's these rings, there's these rings, there's these donuts, and then I made this. I forget exactly why, but I made it in a different, I guess, I shifted the angle you're viewing it from or something. I forget how I came about this. But then I shifted it again. So this is what it would look like from another angle. Something or other. I know it's very rough at this point. It's a little hard to draw and conceive of, but this is basically you know, what a 4D torus is composed of. So I hope this was interesting and helpful and insightful, and let me know what you think, I guess. Anyway, later.